Alright, what's up, ladies and gentlemen? So we're going to pick off where we left off on lesson 5-1 to 5-3, solving linear inequalities from our Zoom class. Once again, if you want to check it out in your textbook, you can check out these pages right here if you have the textbook, or you can also look at the slides that I posted right here, okay, on your Google Classroom assignment. Right? They have examples that they show you, but we can also work the problems together on the video. So let's go down. We're going to skip the first few that we did together, and we're going to fill out the rest of the table right here for number 5. So let's click on Show Your Work so we can start editing. And let me put this down so you can see a little better. All right, so once again, you can use this zoom to kind of put it closer, and you can use this hand motion to kind of drag it around. So I'm going to work through each of these problems again so that can help you with your quiz that will be due after this lesson. So right here, we're going to write a verbal expression describing this inequality. So since I see that the inequality sign, right, the alligator is eating the bigger number, I would say that x is less than 4. All right, so I want to keep that in my head, that any values of x will be less than 4. So what values could be less than 4? I know for sure I could use 3.99, right? That's really close to 4, but still less than 4. I could pick 1, and I also pick negative 15, right? That's toward the negative direction of the number line. What x cannot be is if they are greater than 4. So if I have like 4.01, right, that's barely bigger than 4, or I pick 5, or I pick 25, right? That goes towards the positive direction, and these are not solutions that I can plug into x, okay? So remember, our definition for a solution is values that I could plug into the variable that make the inequality true. Same thing for equations. You can plug a value into the variable that makes it true. So as I go down here, let me use this drag button. I'm going to graph this, all right? So I know for sure x is less than 4, and x, let me write this right here, okay? X cannot equal 4, right? Because it's always less than. So that means what I'm going to have right here is that I'm going to have an open dot. So you can use this shape button right here, circle. And let's not put a closed dot. So I'm going to have an open dot on 4. And I can pick values of x that are less than 4. So any value right here from 4 onwards, okay, is part of my solution. So that's what the arrow means, that these are the solutions that work for my inequality. Okay? Oh, right there. All right, these are my solutions that work for x is less than 4. Okay? So I will type that right here. Whoops. Okay, so use the text box right here. I'll type that open dot because x cannot equal 4 since x is only less than 4. Right, that's how I would describe that one. So let's look at the second example right here. I'll use this to drag it all the way up. What is this verbal expression? I see that the alligator mouth in the inequality is going to eat the bigger number. So y is greater than negative 3. So let me type that right here. Y is greater than negative 3. So remember once again, these values that I have, right? These numbers on this side, on the negative, this direction is towards the negative numbers, and this direction is toward the positive numbers. So I want to pick numbers that are greater than negative 3 in this direction. Okay. So what values of y work? I can put this right here. And you can say negative 2 is greater than negative 3. I could say 0 is greater than negative 3, and I also could say 10 is greater than negative 3. What y cannot be if there are values that are less than negative 3. So I could say negative 3.01, you say negative 5, and you say negative 10 as well. Okay, so once again, this is only y greater than negative 3, so y cannot equal 3. Okay, so y cannot equal 3. Okay, so if y cannot equal, negative 3, right? If I put the dot, it cannot be exactly on negative 3. So I'm going to leave it as an open dot. So let's use my shape once again, circle right here. And then I'm going to pick a line that goes towards the values that are greater than negative 3. Right? So then I go down, and then I'll put this text box, put it right here. I would say that I would have an open dot still, okay, because y cannot equal negative 3, negative 3, since y is only greater than negative 3. Okay, so that's an explanation for that. I'll do one more, and we're going to look at the reason what happens if I have a, let's see, a less than or equal sign. Okay, so the alligator mouth is eating the negative 2, so that means negative 2, let's do it like this. A is less than or equal to negative 2. So let's put that in words. A is less than or equal, equal to negative 2. Okay. So now let's think of what values of A could work as my solution. I can say it can't equal negative 2 because, once again, this is saying it could be equal to negative 2 still. I could also say it could be negative 2.01, because that's still less than, and let's say a negative 1,000, right? That's definitely a lot less than negative 2. The values of A cannot be values greater than negative 2. So even if I had negative 1.99, right, really close to negative 2, but still greater than, I could do 5, and I can even do 1,000. Right? Those are values greater than negative 2. So in this case, I can see that because it's saying A is less than or equal to negative 2, A can equal negative 2. So if it can be exactly on that value, that means negative 2 is part of the solution. I would draw a closed dot when I have a less than or equal to negative 2. So let me draw that circle once again, and you could press this button right here to fill in the circle, and you put it right on negative 2 like that, and then you're going to draw a line that goes to the values less than negative 2. So we're going to go in the negative direction that way. That's how you would graph it. And then when I go down to my explanation, put this hand, scroll it down, I would say close dot because A cannot equal, A can equal negative 2. And so let me see like this. So negative 2 is part of the solutions for A is less than or equal to negative 2. Okay? So remember, a solution for inequality is a value that you could plug into the variable that makes the inequality true. Right? So the values that work when you plug it in, and it makes the inequality true. So look at that, okay? And then I want you to try the last one by yourself. All right, go for it.